What's wrong? What? What is that? Why did you do that?
Sorry?
Why did you do that?
No, it's automatically.
Sure.
Yeah.
Okay, Sean!
Yeah?
Put it back. I'm hungry, come on, leave me be.
This is not good.
Oh, why no porridge today?
I did, it's not enough.
Ah.
It's not enough for you to maintain the office.
It's not enough. Jerry, he stresses me. Makes me hungry. I can see the bag of crisps open from here. Oh, like that, huh? Like that. No, Sharon, you have crisps, I got nothing. You have 2 pastries, I got nothing. Yeah. It's okay, Jerry. You need to eat. I'm worried about your weight. Right. You had a breakfast roll, and what did I get? Not even a sausage from your breakfast roll. I guess I'll just starve to death. Right.
You have class until 2.
Until 11?
No, I mean...
Yeah, I have class until 11. I don't know how I can make it.
How we make it to 2?
It's a bit weak. You just had breakfast.
Well, it's
2 o'clock.
No, it's until 2. No, it's until 2. 3 hours. Yeah.
Okay, Lee! No, Lee! We all know Monica's wrong. Now put the phone down.
Okay. Yeah.
Oh.
So 1 is the...
Hello.
So I told...
Do you know, Christy, I would like one, thank you.
There was a big mouth.
Do you know what?
Do you have class
I never tried this.
It's okay. I found some food.
Nice.
Okay. Did you keep these in the fridge? Interesting. Okay. By parts. So, this is when we want to integrate something which is a multiplication. So basically, it's kind of like a product rule. What's wrong, KJ? Okay. It's kind of like a product rule. Let me give you an example. If you had something like this, how could we integrate this? Well, we know how to differentiate it. How do we differentiate it? Product rule. But how do we integrate it? Well, there is a rule called by parts, and the way it works is if you have 2 functions, and we'll call them u and v, and we want to integrate it. Yeah. I suppose. Well, I don't actually like using u and v. I've gotten into the habit of using f and g. So we'll call 2 functions f and g. But instead of calling the second function g, we call it g derivative. So in this example here, this would be f and this would be g derivative. The integration by parts rule says that this can be simplified into this. Integrating fg derivative is equal to fg minus integrating f derivative g. Now you might be saying, how on earth is that helpful? Because all I've done is taken one integration and changed it into another integration. But in fact what we'll discover is that this often simplifies the problem. And I'll show you with an example. But first, this is the rule. You want to write it down?
This is a part.
I like UV better. Nick, you write down with UV.
It's the exact same rule, just using how U, V. Now in the formula book in the exam, they write it using U and V. I feel that looks a little bit confusing and messy. I prefer using F and G. It's a little bit neater. Yes?
What is DV?
Well, I haven't done an example yet, so I'll do an example to illustrate how this rule works. Yeah?
UDV.
So I can cancel it.
Yeah.
It's just a big fine.
VU.
Yep. Goodness sake, you're all annoying me now. You can write it like this. This is one way to write it. This is another way to write it. Another way to write it's like this.
Yeah, that one. I love that one.
No.
It looks good.
No.
And another way to write it is like this.
UDV.
Yes.
Yes.
Now I think I've covered all the ways you might have seen it in school.
Yes.
Because the first one is to watch the formula application. I mean, the correction practice.
That's not what I said. I said, this is the one in the formula book. This is the one I use. This is the one that Sean used. And this is the one that Chrissy wants to use.
No, I like first one better.
So why did you ask me to write the other one if you like the first one better?
No, I think the first one better.
The fourth one?
Yeah.
That's actually what I learned in school.
That's what I learned in school.
Okay.
Okay.
Now that I've written this rule 4 times, let's see how to use it. Can I scroll down? So, let's use the example I gave. This is how I like to do these. Keep it nice and simple. Draw a table and write here F derivative, G derivative. So, we call this one the F, so the X goes there. And we call this the G derivative, so that goes there. If I know what F is, do I know F derivative?
1.
1. And if I know what G derivative is, then integrate and give me back the G. Very good. So according to my rule, to integrate this, it should be the same as F, G, minus integrate F derivative G, which is another minus. So my question becomes this. So I've changed my problem from one integration to another. But I hope you can see that this is now a very easy problem, whereas at the beginning I had a very hard problem. So the answer is this. Yeah. Now, it seems like a lot of you have seen this before.
No.
No?
Never.
Never? I guess maths isn't so good in China. It's my joke. Of course it's not true.
Yes.
What?
No,
China's very good at
it's
maths.
not very good.
I mean, our direction is different.
Oh!
And we
But-
always met like 3 or 4 kinds of
3 or 4?
like we do this kind of
That sounds complicated.
This is in university.
Yeah, yeah. Now, you might like to know that this problem is it is the same as this problem. What's the only difference? I did a bit of a swap. Mm. Don't make me slap you. You know that's not it. Swap them. But in fact, if you tried this method here, you'll find it will not work as nicely. So in fact, the order does matter. Putting the X before the sign makes it easier to do. So how can we know if we should swap them or not swap them? Well, there's a word here to remember the order. You should first have logs, L, then you should have inverses, like sine inverse, cos inverse, tan inverse. Then you should have algebra, like x, x squared, x cubed. Then you should have T for trigonometry, sine, cos, tan. And lastly you should have E for E, exponential. So this is logs, inverse, algebra, trigonometry, and E for E. So you can see here which is first. Well, algebra is before trigonometry, so it means this should be before this. In this case, it's wrong. We should swap it back. So this is just it's a little useful trick to make the problems a little easier. Now, what is E?
Oh,
E is E.
Oh.
which
Good point. 7. 7 yes.
Oh, no, don't do that.
This E.
That is gas, right?
No. Google it, it's exactly right.
Oh, Lord,
Continue.
Oh, yeah.
Now, I have two more important examples to do, but just before I do two more examples, they get a little harder. So this one wasn't too bad. The next example I'll do will be a little bit harder, but before I do it, I just want to give you an easy one to practice. No, that's not true. I have 3 more examples. Can I scroll down?
it's TRIG1.
It's so hard.
Trigonometry.
Is that
What? Can I continue?
Yeah.
Okay.
What's so hard?
There's no or. Liate. Okay, try this one. Okay, try this one, please. Oh, damn. Finished, KJ? Yeah? Right, what do you need to do first?
Order.
Order.
Yes.
Okay, so let's have a look here. F derivative, G derivative. Well, this is nice. This is X and this is 1. This is E and this is E.
Yes.
So the question then becomes FG minus F derivative, which is 1,
Yes.
G.
Yeah.
And that's nice because that then is X, EX minus EX plus C.
Yeah.
Okay, next example. Quickly, Jerry. Quickly! Reese's square?
What's the square?
What is that?
It's biscuit.
What?
Peanut butter biscuit.
Yeah, American. American?
No. Why is it? This is American.
Americans like their peanut butter cookies.
The peanut
And
butter
this
cup
side.
is up.
No, this is from Malaysia.
Huh?
Honestly.
I'll keep it. Right.
Gosh, what?
I told you he's a racist.
Look, Christy, we're all racist in this classroom.
that's
It's
true.
okay.
Sorry, Monica.
What? You're not taking me seriously, are you? Right, continuing. So, Jerry, you got that?
Yeah.
Okay. Next example I want to do is this one. Continuing. So, here, what's the F? X squared. So what's the F derivative? 2x. The G derivative? Sine x. And the G? Minus cos x. So if I use my rule, I'll get F G minus F derivative G. Ah, but now I have a problem. Apart from Lee Win, what's my other problem? So what's my problem now? Something has gone wrong.
Yeah.
Well, not quite gone wrong, but not quite as nice as last time. What's happening?
You
have to do it
again.
I have to use the rule again, because I haven't fully simplified my integration down. Alright? So, once again. Are you okay, Sean?
Yeah.
Do you need to get water? F derivative, G derivative. 2x, 2. So I'll just write down plus a new problem now. G derivative and G? Sin x. I had 2 minuses, Monica, so it became a plus. Okay, so now I get this. F G minus F derivative G. Alright, well that's good. Now I can complete it. Integrating sine is minus cos. Tis. Did you write this down?
Teacher, can you write that in the exam? New. New.
Yeah. Plus new problem. Continue? Yeah? Okay, let me give you one that requires the rule twice or more.
Come on.
One more. I guess you'll have to see for yourself. Integrate this. See what the fudge happens here. What the fudge, yeah. You know something happening? Very interesting.
To pull everything out.
Yeah, so just let me know when you finish integrating. How many integrations are needed? Infinite? You think you can get that finished in a few minutes? Just integrate infinitely, please.
Infinite.
Yeah. So could you just hurry up and integrate that an infinite number of times, please? We know this, you know, have things to do. What? She's fine better. Okay, so you've all spotted the problem. Yeah, so let's have a look. I hope you all recognize that the very first thing to do is this.
Yeah.
Okay, so F derivative
Yeah.
EX. Well, that's nice. Yeah.
Yeah.
So now your sin x EX dx becomes F G minus integrate F derivative G like this.
Yeah.
So now this is a new problem. Alright, well, let's deal with that again. So underneath cos x minus sin x EX. So now this becomes sin x EX minus, and then I'll put brackets in here, F G minus integrate F derivative, which is another minus, G again. So this becomes sin x EX minus cos x EX plus integrate sin x EX dx. Alright, this might take a while. 2 down, infinite number to go. So continuing here. So obviously this is not going to work. Although I have done it the right number of times. 2 is the magic number here. But can anybody see what the next step is to prevent me going to infinity?
I know.
What?
I really thought that was the answer.
No, not bad. Not bad, but actually we can get an exact answer. Yeah. Now, sorry, I apologize. I made a sign mistake here. That's a minus. I just saw minus is minus. You're not quite wrong. Not cancel each other. Not dot. Now let me help you a little bit. Just remember, I'm trying to find this. I am trying to find this.
Oh, it's
Okay.
only 2.
Move that to here.
There we go.
Oh.
Boom. you mean, how does that help? Done. Quite interesting. Quite interesting. You've not seen this before?
No.
So write this one down. This is common enough in the exam. That's everything here, isn't it? Yeah.
Isn't it the sign that we could see access the accent and fx and find access to
No, the order is important here. The E should be on the G one.
Well, I did it another way, but I got the same answer exactly.
What other way?
I put E as the fx and then try next to C.
In this example, in fact, yes, if you swap the order, it still works, yeah. For this example only. Yeah, it'll still work because the same problem happens of rotating through the functions. Okay. Yeah? Continue? Yeah. Right. Continuing. So, what's really nice about this is it can let us do problems that we can't do. It seems like we should be able to answer a simple question like this. Integrate log x dx. What is this? It's not 1 over x. Not. Because you're thinking of the other way around. It's 1 over x integrates to log x. But I never told you what log x integrates to. We know the derivative of log x. The derivative of log x is 1 over x. Okay, we know the derivative of log x, but we actually don't know the integration. So what do we do? Well, there's a trick here. We'll change this into log x multiplied by 1 and use our method. F derivative, G derivative, G. Yeah. So this is equal to F G minus integrate F derivative G. Well, that's just 1 over x. What does that integrate to? Yeah. So the answer is x log x minus log x plus c. Or in other words, x minus 1 log x plus c. That's actually the integration of log x. Yeah. This is the trick here. I've seen this in the exam once, where they asked you to integrate something like what one did they ask you to integrate? Sine inverse x, I think it was. Yes, or tan inverse x. Let's actually look at that.
Is that proof? Is there any proof for this formula?
For what formula?
G minus...
No. I mean, I can give you the proof. It's very, very short.
It's short.
Okay, like 1 line.
It seems very long.
Oh no. Can I scroll down?
Yes.
Right, before I do another example, just a very short proof of the integration by parts rule. F derivative g equals fg minus integrate f. Oh, sorry, that's the wrong way, isn't it? Minus f derivative g dx. Okay, the proof of this rule. I differentiate everything. So what's the derivative here? It would just be this. Why? Well, the derivative and the antiderivative, they cancel. What's the derivative here? I need the product rule. Yeah? And what's the derivative here? That's the end of the proof. You ended with something obviously true. Fg derivative equals Fg derivative, so proven.
How come integration fg equal to integration fg?
Huh? How come what?
I mean, our question is integration fg.
Integration Fg.
Yeah, but we rewrite as integration fg.
No. We're just simply calling this f and calling this g derivative. They're only names. I can call them anything. I could call this one theta derivative and this one omega triple derivative. They're only names. They're. If I called it f and g, then it means later in the formula when I refer to this, that's actually the integration of what was in here to begin with. It's more convenient to begin with calling it a derivative rather than having a double integration in the formula. Okay, so let's have a look here. Integrate tan inverse x dx. Well, let's use our trick that we just learned. Change this into a by parts problem. I'll simply put in a 1. L-I-A, so the A should come after the I, so I'll put the 1 at the back. So according to my rule from today, this is f, and derivative is 1 over 1 plus x squared, because earlier today we said the integration of this is that. And this is a 1, and this here is a x. So this is equal to f g minus integrate f derivative times g. Now this one isn't actually too hard. We've seen this one today. In fact, let me make it even clearer for you. I'll change this into minus a half integrate 2x over 1 plus x squared dx. What's the trick for doing this? What's the I'm putting the half and the 2 to really drive home the relationship here and here. Yeah, so we learned what to do in such a situation.
I square over 1.
No.
Rule?
No. Just that. So what's du dx? 2x. No. You're thinking of the last example where it was a constant over a quadratic depressed quadratic. This is a linear over a quadratic. This is our first example we did today. Yeah, 1 over 1 plus x squared, but this is 2x over 1 plus x squared.
1 over u.
Huh?
Log u.
Yeah. What are you asking me? I put the half in to just make this a 2. I didn't need to do that. I was just trying to get you to see how the derivative here is this. I really just wanted to remind you that this is like our first example we did today. This becomes x tan inverse x minus a half integrate 1 over u du, because this will become a du over 2x, so it cancels. So that's nice. So that will become x tan inverse minus a half log u plus c. So the integration of tan inverse x dx is all of that.
Is X times inverse 3?
Here at the front.
X times inverse.
Oh, sorry, of course, it should be a X here.
Teacher,
Yeah.
do we need to change the sign of the?
Yeah.
Okay.
Yep.
And then see like, no, the first line, x times that x minus integration of that 1 over 1 plus x squared becomes x. So what do you have?
Say again, sorry, which one? Is it this part?
The 1 over
This
2.
part?
Yes.
What's wrong with this part?
To make it 2. And to cancel.
Yeah. I just put the X here, and I put a 2 and a 2 here. My purpose was to make this exactly the derivative of this. That way, when I use this substitution, I get a very nice simplification.
What is the zone?
No problem, you'll just end up carrying a constant. You'll end up with the same thing.
Oh. Oh, yeah. That's all.
Yeah.
Yeah.
Yeah. Yeah. How many cookies are in that bag? Seems like
No.
This is-
Only 4.
all right.
You want?
That's okay. It just seems like there was no limit to it.
It's not.
Okay, did you write that down?
Mm-hmm.
I've seen this one in the exam. In other words, all the examples I've done today have appeared in the exam. So they're all exam problems. The only thing I haven't done, but it's not really a big deal, is if I put limits here and here, then it just means at the very end you have limits here and here, and you don't care about the C anymore.
Mm-hmm.
Hardly a big deal. Yeah? Sometimes students get a little bit confused if they should include the limits on this because the integration was only a here. But no, it is on the whole thing.
Oh.
Yeah? So in other words, back in my formula here, if I have limits here and here, then there's limits here and here, and also here and here. It's the point I'm making. Happy with that?
No.
Yeah. Someone was asking me about tutorials. So just to be clear, when is our last maths class of the week?
Tomorrow.
Is it?
Yeah.
Good accent.
Yeah.
Maybe.
Do we have a double class?
Yeah.
Okay. So in the second class tomorrow, we'll have a tutorial then.
No.
No?
Tomorrow afternoon. Yeah.
Tomorrow will be a maths tutorial. Do we have physics tomorrow?
Yes.
Great.